So for section, what is it, 2? For section 2, it says we have an angle in quadrant 4 because x is positive 2 and y is negative 2. So this section of problems is exactly like the ones we finished before. They just wrote it differently. We have an angle in quadrant 4. X is positive, y is negative. Jan Grant?
Yeah.
Okay. So now we're going to find all of our stuff. How do we know it's in the 4th quadrant? Can somebody explain that? Where the point is. So where would you plot the point 2, negative 2?
Oh, right.
So 2, negative 2 is going to get plotted in quadrant 4, right? So Zion, what happens next? What do I do now? What's the next step? I need to answer those questions. Find the hypotenuse. And how am I going to find the hypotenuse? Pythagorean theorem. That's right. We're going to use good old Pythagoras. So here we go. We're not going to worry about the negatives because we're squaring. So 2 squared is 4. 2 squared is 4. So x squared is 8, and x is going to be the square root of 8, which is 2 square root 2. This is 4. Do I need to reduce my radicals? Of course you do. Of course you do. Now, here we go. Sine. Here's theta, always at the origin. Sine. Negative 2 over 2 root 2. Now, kids, this doesn't happen very often, but we can actually reduce that, right? That's going to reduce to negative 1 over root 2 because these 2's are going to cancel. Now, I'm going to skip over here real quick and say that means this is negative root 2 over 1. And then I'm going to simplify that, or not simplify, rationalize this, and it would be what? Negative 1 root 2 over 2. That's exactly right. Very good. You all can do that. You just have to slow down a little bit. Now, what about cosine? What's cosine going to be? 2 over 2 root 2? So we'll have the same thing going on. We can cancel. So we have 1 over root 2. Jalen Buford. And then we'll rationalize this and get root 2 over 2. How about tangent? What's tangent here?
2 over negative 2.
Actually, negative 2 over 2, which is negative 1. And then the cotangent is also negative 1. Tangent is opposite over adjacent, y over x, negative 2 over 2. Everybody okay with that one so far? Okay. Well, the next one, we're going to do exactly the same thing. I'm confident you can do this. Which quadrant is this point in? 2. We're going left 1 and up 4. Here's my angle, always at the origin, so this is opposite over here. Sam, what's my radius or my hypotenuse?
Well, you have to do Pythagorean.
So go ahead and do that for us and tell us what you come up with when you do the Pythagorean theorem on this triangle. Remembering that when you square, everything becomes positive. So this is 1 plus 16.
root 17.
Root 17. Does that sound about right to everybody? So here we go. Jalen, Buford, what's my sign? Four over root 17. And I don't know if you heard Jalen or not, but the first thing he said to himself was that's O over H. SOHCAHTOA, O over H, opposite over hypotenuse. So 4 over root 17, which means this is root 17 over 4. And then we're going to rationalize this. Chase Stewart, how does that rationalize? What does that become?
17.
Well, the bottom becomes 17 and the top becomes 4 root 17. Perfect. Beautiful. All right, Megan. I need the cosine now. What's my cosine?
It would be. I'm sorry, I can't think. Okay, cosine is. So it'd be 4 over. Or wait. It'd be negative 1 over 4.
Negative 1 over.
Square root of 17.
Negative 1 over root 17. Because remember, Megan, what needs to be going through your head is SOHCAHTOA. And I asked you about cosine. So you need adjacent over hypotenuse. And you need to be able to look at the triangle and say, that's the adjacent side, that's the hypotenuse. So it's negative 1 over root 17, which rationalizes to what, Megan?
17, or negative 1.
Okay, negative 1 over root 17, that's my cosine. And then I'm going to rationalize that, so it's going to become negative 1 root 17 over 17. Tangent. Negative 4. It's 4 over negative 1, which is negative 4, and the cotangent is negative 1/4. Now I'm going to blow your minds. That's pretty easy. That's what we've done before, not an issue. Here we go. Look at the next problem and tell me what is different about this one. It's what? It's on the line. It's called a quadrantal angle. And what that means is, it is on, when you draw it, when you try to draw the angle, it is on a quadrant line. It is not part of the butterfly bow tie. So everything we've learned won't work on this picture. So, here's how we're going to handle that. We're going to draw ourselves a triangle, or excuse me, a circle.
Nice.
I know. We're going to draw ourselves a circle that goes through that point. This is the point 0, negative 2. Now, because I'm drawing the circle through that point, what is the radius of that circle? 2. So the radius is 2. Because that's the point that I had to go through. See the given here? They're telling me that x is 0 and y is negative 2. They gave me that. They gave me an x and a y. I drew the circle and got my r. Now, you know that sine is y over r, cosine is x over r, and tangent is y over x. Those are the definitions we have to use to answer this question. Now again, if you're having trouble memorizing those, remember that triangle that I drew earlier. This is opposite, this is adjacent, and this is hypotenuse. But this is also x, y, and r. So sine is y over r.
Wait. How did you get 2 for R again?
Huh?
How'd you get 2 for R again?
That point, 0, -2. So if I draw a circle through that point, the radius has to be 2. It's down 2. So the radius is 2. Now if I know those definitions, then I can answer the question. What's the sign? The sign is y over r. So that would be -1. The reciprocal of -1 is still -1, isn't it? What is x over r? Oh, no, it's not 2. 0 over 2 is 0, isn't it? But what happens when I take the reciprocal of that? I get undefined. Undefined. There is no secant for this angle. What's the tangent? Y over x. Wait a minute. Y over x. Undefined. But the next one is 0 over -2, which is 0. You are going to get, if you happen to have a quadrantal angle, you are going to get a lot of undefineds and zeros. By the way, how big is that angle? How big would this angle be? 270 degrees. That's a 270-degree angle. All right, let's do the next one. 3, 0. Is 3, 0 another quadrantal angle?
Yes.
Yep. So I'm going to draw my circle. X is 3, y is 0. What's my radius this time? 3. What is all the chitter chatter? Come on. So let's fill these in now. We're doing this angle right here. So what's the sign? Y over R.
1.
1, y over R. 0 over -3 is 0. And the reciprocal would be undefined.
That's just weird.
What's the cosine? The cosine is -1 because it's x over r. 3, oh no, +1. There's no negative in there. Positive 3 over 3.
So it would just be, never mind.
Yeah, that, I don't know why I put -3, that's not right. And then tangent, 0 over 3 is 0. And this one is 3 over 0, which is undefined. Yeah, there's no negatives in that problem. I don't know what I was doing. There's no negatives in there. So how do we handle angles that are actually on an axis? We have to do X, Y, and R. Jack?
So the radius is always like whatever, like if it's horizontal, then it's always that number. If it's vertical, it's that number.
Yeah, think about that. I mean, if you want to go through that point, yes. Wait, we're not done, we're not done, we're not done. Number 3. Tell the sign, positive or negative, of the sine, cosine, and tangent if you are in the interval pi over 2 to pi. Mason, you guys in all your chat are the reason we're still working. What's pi over 2? How many degrees? Pi over 2? 90. So here's 90 and 180. So you have an angle over here between 90 and 180. That's what it says here in the problem. I have no idea how long these sides are, but I know this one's negative, this one's positive, and this one's positive. Left, up, always positive. Now I want to know if the sign is a positive or negative number. Now stop and think about it for a minute. Positive or negative?
Positive.
The sign would be positive, and how did you know that? You're exactly right.
Plus over plus.
It's plus over plus, because sine is opposite over hypotenuse.
Yeah.
Now what about cosine?
Negative.
Negative over positive.
And then
And tangent?
negative.
Positive over negative. Opposite over adjacent.
That's all you have to do for that.
That's all you have to do for that one. All right, well, we'll pick up there tomorrow. Those of you that have my calculators, I need them back.
Bruised elbow. Billy, you got a bruised knee.
Evan, you got my calculator.
Yeah.
Hopefully tomorrow we'll be back on a regular flex schedule. I need to see some of you during flex.